this video, we are talking about equivalent fractions. How are we going to tell if fractions are equivalent? We are going to look at them, all right? So here you have one whole circle and another whole circle. One whole, that's the same as 1, right? 1 equals 1, we get that. That's really comfortable for us. If we see something like this, well, those two things are clearly not equal anymore, right? And we can see it. We can see that they're not equal. We don't have to know what the fractions are. We don't have to look at some complicated fractions and figure it out in our heads. We just see it. 1/2 equals 1 whole. That's not true, okay? And yeah, I know we have some notation over here. We call this one 1/2. We call that one 1, right? And we write this 1 horizontal bar 2. We created this notation. But fundamentally what we were doing as humans when we invented this notation, when we invented the practice of putting one number on top of another number and then adding a horizontal bar in between, okay? When we decided we were going to do that, we were trying to represent the real world. We were trying to say, okay, I want this to mean this thing that I can see. Because humans are interactive species, right? This is what we do. We interact with the things that we see in the world. This is supposed to represent this thing that I am seeing. And so that's how we're going to do equivalent fractions, right? So, if we look at these two things, we can see that they are equal. 1/2 equals 2 out of 4. There is a numerical process that we will learn in order to work with our, little one number on top of the other number with a horizontal bar, okay? Our fractions written as numbers, I get that. But right now we can see this. We can see that 1/2 also equals 3 out of 6 equal pieces, 3/6, right? Those two things are equal. We can see that these two things are not equal. 1/2 does not equal 3 out of 4. Those are clearly not the same. Over time, you're going to develop a number sense with this, and you're going to know, and just instinctively, you'll feel it. You'll say, oh, no, I know that 1/2 is not the same as 3/4, right? And when you get into decimals, you'll start thinking, okay, I know that 0.5 is not the same as 0.75. I know that 0.5 is not the same as 3/4, right? And you'll get that number sense. You're going to get there, but right now, we're couching it inside of this physical realm, this physical stuff we can see. We can see that 3 out of 4 equal pieces are equal. That's equal to 6 out of 8 equal pieces. 6/8 is equal to 3/4. We can see that 3/4 does not equal 1/3. That's not a thing, right? But we can also see with our eyes, visually, we can see that 1/3 does equal 2 out of 6. It also equals 4 out of 12. Those are going to be equal, right? Identical. Those are the same. But 4 out of 12 doesn't equal 3 out of 6. 3 out of 6 does equal 6 out of 12, right? And all of those things equal 1/2, right? So 1/2 equals 6 out of 12. It also equals 3 out of 6. It also equals 2 out of 4. We had that before. It also equals 4 out of 8. And again, we're building that number sense. We're going to understand at some point, when you divide things in half, if you have 10, you divide it in half, and it's 5 out of 10 is going to be your half, right? 6 out of 12 is your half. And that makes sense. 7 out of 14, right? So we're going to get to that space. But until we have the number sense fully built, and really, really reliable 1000% of the time, we got to rely on our visual eyes, because your eyes can still see that these things are equal, right? Apart from that, you just have to get good at drawing. If you thought that this was a time to be bad at drawing and you thought you were just going to be bad at art forever, don't worry, that's not true. It's time to get good at drawing, equal pieces, ready, set, practice.